Okay. So what is the intention of this session, right? To create like an awareness how to approach the performance testing, right? Again, think this as a quick start kind of thing, right? Even I am learning as we are going ahead. So the idea is to transfer it to everyone, right? And everyone can also start doing the same, correct? And we will also discuss certain, like I think probably like why the optimizations matter even while we start developing code, right? So we'll try to do like a small demo going through the things. And yeah, the idea is that I need to enable everyone to be able to use the load testing techniques as part of the development process, right? And fine tune the performance during that time itself. Because at least now we took it up as an afterthought only when we had the requirement. That's good. For our stage, that was okay. But right now we are trying to go into a phase where the performance is matters more, and we are fine tuning. So once it is fine tuned and we have, let's say, large architectural change or a new feature, right? It is possible whatever things we did, it could deteriorate and the performance could get impacted, right? So if you are finding it out only in a later point of time, right, it's not going to be good. So, and we can individually single APIs or containers where it matters, right? We can do where the load is expected. So developers itself can do a round of testing locally and everything, right? And yeah, the QA folks were very unhappy. Like I kept it like today when all of them are out. But to be honest, the role of QA, they can use the load testing tools to check if our performance had degraded, right? Other than that, when it comes to actually making the performance better, right? Connecting the dots and figuring out where the performance leaks are happening. It's at the end of the day, it's gonna be on the shoulders of developers, right? So this is more engineering oriented and to figure like so how a developer can approach the load test. Again, whenever you do the low level design, right, as a engineer, that's what you're going to be do the most. And uh, everyone should be like, thinking in terms of performance, right? So that's the idea. Let me go to the next slide. Oops. Okay. Yeah, I think that's it. We'll go hands-on, right? So basically, what I have done, I have created an AI. You might be, if I had done an interview for you, right? You might be familiar with this question. This is the one question, easy question, always used to ask, right? Find the first non-repeating character in a given string, right? And I have made it into an API, and we'll try to test it, and we'll see, right, how we can fine-tune this things. Okay, so let me move over to my code. So before that, right, I already have like uh, the things running here. For example, right, I have the this is web one is our application. Everything else is more or less for like monitoring purposes, and some of this is like some other experience I was also doing. So this is what we are gonna hit, right? Let me. I don't know why I'm seeing some other. Okay, it's related to tempo. That's okay. So now I'll do one more thing. Escape plus and let's open the monitoring also. Where is it? Yeah, Grafana. So I have just created like a simple dashboard for this purpose alone, right? Just seeing like what is the memory usage and what is the CPU usage, right? Keep it to 5 minutes, and you can see the CPU usage currently is like very less, right? Not very high or anything, because nothing is happening there, right? And I'll just try hit the API once to show you like what happened. For example, here I have a curve, right, which I can just give me a moment. Yeah, which I can just hit and yeah. Sorry. Yeah, it should give you back like the first non-repeating character, right? And if you had, let's say, no non-repeating character, everything is repeating, then you will get nothing back, right? That's what this API does, right? So that's all that is happening. So what we'll do, we will try to load test this particular API, and we will try different configurations, combinations, and stuff like that, and see how it impacts, right? So let me go to the Docker Compose YAML file quickly to check something. So if you see here, right, okay, I'll limit it to one CPU to begin with. This is a good place to start testing, right? And with one, because that's like a definable quantity. And in Docker, just like in KH, right, you can limit this. If it is not limited, it will use whatever available CPU and everything, right? So we'll limit it to one. And the worker also, I will limit to one, and the threads will be one, right? The reason being one vCPU, and this is a CPU intensive process. Okay, this is not like a IO bound process, because we are doing an actual logic that is just doing for loops and checking for the non-repeating character. Right. So let me apply this once again. Uh, I don't need to build. So I can just apply. Okay. Let me try hitting it again. Yeah. Good. So this is working now. Uh, So before starting the load testing, right, few places where you can check like the performance. So if you are on a Mac, or if you have a Docker desktop, right, you can go here and check the stats to see like how a Docker is performing. But often you might not be using Docker desktop, right? And this is not very reliable also. So that's why you can also do something like Docker Compose stats and the app you want to service you want to get the stats for, right? So if you do that, you will start getting like the CPU usage, memory usage, and some other things as well. Usually we are only interested in like, CPU and memory usage, right? And I'll try one more command, uh, top web. So this is equivalent to top what we do in our local machines, right? So it will show like the threads that is run, processes that are running inside. And since we have a one worker, one thread, right? Yeah, you might expect to see one, but actually there will be two. One reason is like there will be a parent that starts, then it creates the workers separately. So that's why you are seeing two, but yeah, good enough, right? So we'll start and and for this purpose, but the one problem here, this is like instantaneous, right? You don't know have the history. That's where using something like a Prometheus, Grafana kind of setup will be helpful, right? So here we have like the history, what is happening and stuff like that, right? So cool. Let's now go ahead to the load testing part, right? So for load testing, we'll be using a tool called Locust, right? And you can find the entire documentation here. We have already used it in LLM Explorer, and it is committed in the repo. We have a little bit of advanced use case as well, the like asynchronous call, how we are handling and all, right? It's pretty straightforward for a developer. This will be like less than a day to learn and start using, right? So Locust is our only requirement. So if you see, I have my load test files inside here, and I have a requirements.txt, which only has like Locust, nothing else. And Locust will be like a executable CLI tool, right? Now, how do you write the actual test case, right? So if you see here, we are importing few things like HTTP user, between task, all from the Locust, right? And HTTP user is like the class it provides, and we are implementing it as another class. And if you see host is like sorry, the host is where we want to hit our API, right? So right now I'm like running it locally, so it is localhost 5000 or 00. It's the same thing, right? And wait between like in between requests, right? How much time we want to wait? I'll try to reduce it probably to 0.3 and see what happens, right? So these are like configurations we do. Now, if you see each and every test, right, you can actually write multiple tests. Here, since we only have a single API, it will be called perform search, right? And all we are saying, this is the URL we want to hit. And you will see a request happening here. This is very much equivalent to the Python request library, right? You are passing the data as the search string. So earlier, if you see here, our curl, right, you would, sorry, yeah, the curl, right? We are passing it as a plain text directly in the data. So the same thing, just how you might write like a Python request, right? The same thing we are doing here. And what is the actual search data? So I'll go here and it simply the idea was like I took all the ASCII letters, right? And the last one alone, I made it non-repeating, and I'm just repeating everything else like 100 times, right? So the idea was I wanted to generate like a really, really huge string, right? So it's not really very huge, realistically speaking. It's just like what I think 5,000 characters or something, right? That's all it is. But yeah, that should be good enough for our current testing and demonstration purposes, right? And yeah, it will be generated and that will be passed every time into the API request, and we'll be measuring that basically, right? And one thing I would just like to point out here, right? Even if you see here, yeah, it's very small things, but it can make all the difference, right? I am doing this outside like the class or outside the function. Why? Because it is something that is repeating, like it's a one-time thing, right? You don't need to generate the thing search string every time. So, for example, if I had added it inside here, right? This means every time we hit this line number 30, right? We are going to spend some time generating the string, which is completely unnecessary. So these are some of the things you can think, right? Even when you are writing some code, if it is something like one-time generation, how we can like avoid repeating the same thing, right? I think at compiler level it might optimize, but it is best to write the code in a way like we don't do that. It is much more intentional, right? That way we know this happens only one time and it is a constant. It's not going to change, stuff like that. All right. So if you see, this is the entire test case. Everything else is some supporting, yeah, for our generating the string alone. Right? Now, how you run it? If you come here, I have already done the pip install requirements and everything, right? So you write locust -f to provide like the file where we want to run it, right? So it's in the Lotus main.py. You just start it and it will bring up a web interface. So there is option to run it in headless mode also. But for this purpose, we'll start with the yeah, headless, sorry, with the web interface, right? So here it is always a good idea to have like a baseline for the current setup, right? So what is that? Currently there is no traffic, right? So this is also why it is much more easier to do it in local, because in a staging environment or somewhere, right? If somebody else could be using the system at any time, right? And that could skew your results. But here I have complete control and it's isolated load. There is no other request happening now, right? There is no CPU usage, nothing is happening. So I'll start with like maybe just one number of users, and then let's see what happens. Yeah, it's pretty fast. We are getting like 560 milliseconds of response time, right, as a median. If you check the graph. Okay, so this is how you use the locust, right? So I'll just stop and restart just in case somebody didn't get it right. Let me, yeah. So whenever you come for the first time, for example, let me close and restart again. I think I need to keep a history. Let me start it again. Yeah. So the very first page will be asking you like, how many number of users you want to simulate, right? So this is basically going to be your request generator, right? So if you give 10, it will generate 10 requests in parallel from your client side, right? And if you give one, it will have only one. So that's the basic idea. And ramp up is basically like how many users you want to start, right? So you can even give something like 0.01 if you don't want to like, only create few users every few seconds or something like that. So it's just all something you can like, play around and change. Usually these are the only two options I like, use, right? Advanced options is to stop the run after time. Usually I don't use this. In headless mode, it will be useful, but otherwise not really, right? So we'll start with one, right? Once you click start, it will start making the request, right? So this is like a overall statistics, what it shows. it will say how many requests we done, how many of it failed, median time it is taking to respond, right? And the average time is here, the 99th percentile, right? Uh, it's here, and our current RPS. This is the dynamic, as in, like, if you change the number of users, this will also keep changing. So I can also show here like the charts. Charts are very useful when we are so the at the very bottom, right? This is the first place you can check if we have, like, the configured number of users running. Then if you see, right, we'll get the response time as a graph, and you can see we are more or less below 7,000 milliseconds, right? And I have added the 50th percentile and the 90th percentile as the graph. This is a configuration again. You can control, or it will just give you, I think, the 90th percentile by default, right? And it will also show the current RPS, right? So we are hovering around 1.2, 1.3, right? Now, just in this experiment, I have some assumptions already going in, because my is a CPU intensive thing, right? So I have only allocated one CPU. So even if I give, like, do more requests, right, the performance is probably going to get impact, and it is probably going to come down, right? We can verify that theory. Again, if you see here, even now, right, the CPU usage is not really very high. It is still very low. Okay, sorry. I think it's just updating, but it's up to 74%, right? So soon we'll be hitting 100. So let's see what happens. Now, what I will do, give me a minute. Yeah, if you have any questions in between, just please feel free to stop me. Okay.
Ritik, can you
Yeah,
elaborate on the percentile
percentile.
meaning? So when you talk about 50th percentile or 90th percentile, what
Yeah.
exactly are
So
we?
the exact definition I don't have right now, but I think roughly translates to, let's say, like, we get 10 calls, right? The average is like the average response time of every call, right? But when you
Mm-hmm.
say 90th percentile, that means 90% of the users minimum got that number. So here, if you see, right, we have a 90th percentile of 99th percentile of 1 second, right?
Mm-hmm.
That is probably going to be the worst, because 1% we can here and there, like, issue, right? So that is going to be like the worst case kind of scenario someone might get, right? But that doesn't mean everyone is getting that. So this is like the percentile is like a very common concept when it comes to performance testing, right? So for our organization, we might not be interested in 99 percentile. We might be interested in 90th percentile, right?
Mm-hmm.
It's up to us. Like, usually industry standard will be 99 percentile, but again, it depends upon the kind of the use case we are doing and everything, right? So I think that's why here, if you see, I only kept 90, not 99, right? Because when we were doing LLM Whisperer, I think this is what we were. And for LLM Whisperer, even this one making it very good was very tough for us. So, but these are, like, the cues you can use to. So I think there is this concept of like SLAs, and I forgot the other term. So where we will say, right, our service will perform like this, and this will be the 99th
Mm-hmm.
percentile performance or 90th percentile performance, right? So usually to give out that numbers and for ourselves to have, like, the benchmark, that is why we have this percentile concept. I'll share some probably some links where it is explained much better, right?
Sure. Yeah.
Okay. So anyway, I'll go ahead and now try to keep the count to 2, right? Now let's see what is happening. Here we are already using around yeah, 80 percentage of the CPU, right? So this means we are already, like, utilizing our CPU very well, right? So probably we are not going to see much of an improvement, and it is visible right away, right? If you see the response times now, right, it almost doubled, and in some case it is even worse, right? I think we are getting around 650. Yeah, I think it almost doubled, right? So this is something which you can consider as a performance degradation, right? In an ideal scenario, this should happen like when we are under extreme load, right? Here we are not even talking about like extreme load, but we are already hitting like, the response time has kind of like, dropped. The RPS might be okay. Ideally, this RPS should have been double, right? But we are nowhere near it. We are only around like 1.5 and something like that, right? And if you see here, we will be almost hitting like the 100%, right? And I can show the same here in the Docker stats, right? So it is 100%. And throughout this, like as long as our allocated CPU is one, right? This will never go about 100%. But let's say if you had allocated two CPU, right? This figure is expected to go up to 200%, right? So our goal will be to make sure we are utilizing the CPU available to the fullest, right? And also with that, how to bring the best and efficient performance, right? That is going to be our goal as an engineer, right? So now let's see and fiddle around and see if we can improve this somehow, right? I'll just, so if you see, right, you can stop and reset and run, but to get the historical data, I just edited and made it two, right? And I think I can show like maybe one more number just to make it interesting. Maybe I'll go for, let's say, 10 users, right? It's a very high jump, but in interest of time, I'll just do this and let's see how our system behaves, right? So we have some, yeah, references later when we make some difference. So it takes some time for the 10 users to ramp up, right? So this is controllable, right? If you want to create scenarios like, a spike in the load or a gradual increase in the load, all that can be designed. Actually, there is in Locust, they have a method to do that, and or I can share some documentation, right? And you can refer if you're interested. Uh, but you can see the performance has deteriorated even further, right? We are now looking at 6.5, and if you see here, right, we'll be constantly hitting this. So this is the place where we are probably it is not even using more CPU, right? It's just at the limit of whatever we allocate, right? Cool. All right, now before okay, at this point, right, I could try. Let me stop this. Yeah, I could try and increase my worker count and thread count and stuff like that, right? But at here, at this point, it will not even make much of a difference because we are already using the 100% CPU. Let's say if we are not using the 100% CPU, right? That is when we probably want to think about like, increasing either of these. If you are able to hit the 100% CPU, even with this, that means this configuration is already good, right? So now we have only option is to try and increase our CPU, right? So let me just make sure what was my point. Increase the thread to 4. Okay, so we'll try more CPU now. Okay, so I'll keep the limit to 2, again here to 2, and let me redeploy this. Okay, I think we are up and running. I'll just try one. Uh, okay, we are up and running. Okay, now since we have increased our CPU reservation and limit, right? So one thing you need to understand, the reservation means this is like the maximum, sorry, the limit means this is the maximum it will allocate. Reservation means that is the guaranteed always available, right? When you are running locally, there are other variables like your local system is using CPU and everything, but in K8s or some other places, right? This will much more relevant. So I could have kept it like 1 and 2, but the problem is this doesn't guarantee the 2 is always given to the container. This guarantees the 1 is always given to the container. The 2 is given when the 2 CPU is free, right? Otherwise, it will be throttled to 1 CPU. So you can give even fractional numbers, but usually for high load applications, right? fractional numbers doesn't make much sense. There are scenarios where it might be used, but for this purpose, we can, again, as said, right, to isolate it and to have like uh, what you say, hard limits, right? It's better to keep it both two. So it's running. Let's go back and run the thing again. This time again, I'll run with two users. Sorry, one user to start with, just to see if just adding a CPU does it make any sense, right? So does it make any difference? So if you see earlier, right, let me actually do something. Download that. Download report. Okay. Yeah, I think it's a new report. I lost the old report. Oops. Yeah. So if you see here, right, earlier we were getting like 580, 640 and stuff like that. So if you see here, right, again, we are kind of seeing for one request, we are again seeing like, similar performance, right? And it makes sense because I haven't written a code which is doing multi-threading or anything like that. And that's usually the case. So that means any thread that is running, right, it will at max anyway use only one CPU. It is not gonna be like just because you throw more CPU into the mix, right? It doesn't mean everything will start working better, right? Because the reason, the unit of the logic that I'm doing at the end of the day, it is going to be a single Linux task, right? And that will anyway be able to use one core at a time, right? That's how the Linux threads and tasks work, right? So uh, this is why you can't expect any more improvement just because even if you keep adding 8 CPU, right? For a single request, you cannot expect any more performance by adding resource, right? So that's the hard limit if you see. And if you see already, yeah, we are again around the 80% mark, right? I think with the two users earlier we were going. So we'll try two. We are going two. And you can see it is more or less similar to earlier, right? We are getting, yeah, I think almost exactly the same numbers, right? And if you see the CPU usage, let's wait and see what's happening. Let's check here. This is much faster. You can see we are hitting 100, but our expectation was it should be hitting 200, right? We are not. Maybe the request is not enough. Let's try adding more requests, right? I'll straight go to 10 requests just to see if I can get the CPU loaded and see that 200 figure, right? Because now that is one thing you need to understand, right? When you, for example, take something like htop, I think htop doesn't show it. Yeah, this percentage in the Docker stats, right? This will go in multiples of the cores you have. So if you have one vCPU, it will always be like max will be 100%. But if it is two vCPU, this is supposed to go above 100 and it should reach 200, right? This was kind of the issue once Cybersoft reported us with Azure, right? Even though they added like 8 vCPU or anything, it was using only 400 vCPU, right? But it is supposed to go even up to 800 vCPU. That was some configuration issue. So we'll see what happens here. So now if you see, right, we are more or less seeing the same performance, right? No improvement. We have added like the more CPU. And if you see, we are hitting the 100%. It's not even going one, like, let's say 10% above 100, right? So yeah, I think we already faced this before. Anybody, any guess why it might be happening? Yeah, any volunteers?
Is the
Why
number
is
of
it?
threads or workers is the same?
Yeah, exactly. Right, because what does this mean? This means, okay, let's go back to here and let's take the Docker top, right? Yeah, I am. Oh, okay, I'm sending like 10 requests, right? You might expect to see like 10 threads or something, but the threading is not handled by us, right? But it is handled by the gunicorn. I'm okay. I'm actually using gunicorn here. So it anyway only allocates one worker thread. That's what we are seeing here, right? So no matter how many requests I'm sending, right? It's always going to one worker. and the other requests are basically waiting in the queue right now, right? That's why it's not going up, right? So let's try to improve this, right? So we'll try with the threads first, right? We'll make the threads, let's say we are having two vCPU, right? So I'll keep it two because it doesn't make much sense to probably go beyond that, right? And we'll deploy and we'll see what happens. Okay. I think I need to stop this. Yeah, you'll start seeing failures. So here you can see failures and why the failure happened. And if there is like other details are also there, like logs and all, but I think, yeah, good. So I think it's up and I'll try the curl. Okay, the curl is working. So now let's check the top. Okay, now if you see, right, we said how many? Two threads, right? But I think it's only appearing one thread. Let's see, let's try hitting, right? The thing with threads, right? It will only show like it will only allocate it as it is required, right? It's not gonna be like if we mention 1,000 threads, it will create the 1,000 threads at a time, right? So we can verify that by just sending like two requests, right? I'm not gonna bother sending like one request at a time because that anyway we established that is the baseline performance and it will not change, right? So we know that is around like 600 milliseconds, right? So I'm starting with two, and let's see what happens this time. Okay. Before that, yeah, two threads are the okay. The performance wise, we are not really seeing much of the improvements, right? It is more or less as it was before. You could even say it's a little bit worse, right? Because the 90th percentile is now 2,500. Earlier, I think it was at least 1,200. Even here, it was only like 1,500. But here, consistently, it is kind of bad, right? Let me just check the CPU usage. I think I can do, okay. Yeah, the CPU usage is again like hundreds going like little bit above 100, but we are not seeing 200 or anything, right? Let me just ramp up the request load to 10 to see if we can get it to the 200, right? Let's say if we are halfway. Yeah, we might go a little bit over the time, guys. I planned it as two-part session, but I think a few things I wanted to complete within this one. So maybe like 20 minutes we might go over the time. Just giving a heads up. Okay, now we can see with the 10, right? It's much more evident. The response time is much worse than even earlier. Right? This doesn't make much sense. We are increased the threads, but it's going like very worse. And yeah, if you see here, right, it's still not going above 200, right? So almost uh, sitting in like the hundreds. Now, any guesses why that might be like happening, right? Any volunteers? I guess I okay. I hope just in case this is a specific scenario for the Python, especially C Python, right? Um, so the every process is executed as a Linux task in the OS, right? But what happens in case of Python? Python has something called GIL, right? Global Interpreter Lock, which basically makes sure like when the between threads, right, it locks based on the CPU usage. Essentially, what does that does mean, right? Even if you create like threads in a CPU bound use case, right, it will not have any actual like effect because it will end up acting like a single threaded application. That's why you are not seeing much of a difference. And why it might be getting worse is probably because there is now earlier it was a single thread, now it is two threads and it switch is happening between threads and all, right? So that's why it's probably even worse, right? So, but if you see in Python, in such use cases, we use multi-processing instead of threading, where you want like proper allocation of CPU happens, and it can run parallelly in different cores and all, right? Uh, in that case, you use multi-processing, and it will have its own memory space and everything, right? So it's just equivalent to running two different Python code at that point. So in case of Gunicorn, the workers does that, right? Workers are equivalent to multi-processing, right? So at this point, what we will do, we'll go ahead and change the worker count and we'll redeploy and we'll again, run it and see what happens.
So,
Yeah,
Ritik,
Chandru.
you mentioned that it's because it's Python, when we set it to one worker and two threads, we don't really see this benefit, right? Because
Yeah,
essentially only one request is being served at a time, right?
yeah,
Due to the GL.
yeah, even in Node.js, I think Node.js anyway, I think only uses one vCPU because it's asynchronous, for example, right? It's a language specific thing. Yeah, again, true. And we can see later where it makes sense to increase threads, right? In Unstract, we did it already. When it is IO bound, right? IO bound are the things when it interacts with, let's say, something like a file, network call, or even like keyboards and everything, right? In such spaces, it will make sense, but I think
Mm,
probably in the next session, we'll explore that.
got it.
Okay. Was your question along that line
Yeah,
or
yeah. It was like, why is
Mhm.
gunicorn exposing such a parameter if
option
it's
at all?
written?
Yeah.
Yeah.
Okay. Good. Now let's reapply this again.
Yeah, Ritvik, but isn't there a
Yeah, man.
formula, man? G unicorn 2
See, the
into
formula is like the standard guideline. Okay, the formula doesn't mean that's what you need to use. But
okay.
again, if we had followed the formula, I think we would have already kept it as two instead of keeping it as one. Right? But
Hmm.
the number of workers almost always it is dependent upon like how many CPU you allocate. But the
Hmm.
threads usually depend upon like what kind of workload you have. Right? Is it CPU bound or is it IO bound? Right? Based on that. Okay, let me run it again. Okay, okay. Now we are increasing the worker to one, right? And I'll keep the threads one only. Let's check the top. Okay, yeah. Now you can see because it started like separate workers. You'll see like three things. Yeah, I know it's a little bit confusing, but yeah. Now let's if you have added more threads, right, you will see like more things coming up. You can go ahead and check the unstacked and you will be able to watch this live. But if you see now, we have like two workers running. Let's see. Okay, I didn't stop. Let me stop and probably I'll start a new one here because it's okay, it was okay. Sorry, yeah. So I think here chart I'll just reset and okay. So the numbers we'll just keep in mind is like 600 milliseconds, then 1.2, right? And around 6,000, 7,000. Let's see how much we can improve. Now let's see if there is even any improvement, right? So I'll start again with the two to see if there's a difference, right? Now let's check here our this thing. You can now already see we are hitting 200, right? So that means our CPU, whatever we allocated, we are already using almost to the fullest. So that's a good sign. And we should probably see some improvement, but I don't think there's much, right, in terms of, yeah. So now I think something else is happening here. And I need to check my local system also. Yeah, I think we are not realistically seeing much of an improvement here because my local system, if you see, right, being used for so many other things. Right now, I'm doing this. So probably I should have done this on a isolated machine, right? Then at this step, you will see like a actual improvement, right? Right now, we are not seeing it because of like the, yeah, what other things I'm recording and streaming and everything is happening, right? But the thing you have to look out for when you are doing this is like making sure this is able to go up to like the highest point, right? So that we get a sustainable thing. Okay, anyway, now we are sure even with like the two, like, yeah, two CPUs running and everything. It's not impressive. It's okay, but it's not impressive, right? So let's take a look at the code, right? I have uh, intentionally kept the code like, very, what you say, not, yeah. So if you see, right, this is where I'm having the search. There's a spelling mistake, but whatever. Yeah. So this is the first one I wrote, right? And yeah, I think Shua was telling why I always ask, like, when there are like a for loop and a for loop, I comment on that, right? Now you will understand why it happens. So now if you see, right, this is one way, a brute force way of solving this issue, right? You have one for loop going through every character of the string, then you again go through the same characters and check, like, if they are same, expect when it is the same position, right? Then it is obviously going to be same. And you would just return, right? So this is, if you are familiar with time complexities, right? Two for loops means it's a O of n square, right? And O of n square is something we need to try to avoid if at all possible, right? So these are the kind of the things you can keep in mind even when you are coding or looking at making performance improvements, right? If it is not possible, well, but if you have this as a cue in your mind, right? The first solution you try to come up with, you should try to avoid this, right? So this should be like your last option. Uh, Correct. Now, I just want to show one another variant of the same, right? You look at this code and you might think, hey, I don't have two nested for loops, right? So this must be good. But if you see, I have a for loop, then I'm calling another method and it has another for loop. So it is essentially like the same thing, right? So if you are not familiar with and coming to check like for performance improvements and scanning through the code, right? You might think this is perfectly okay, but these two are basically same thing, right? Now what we will do, let me just stop this uh, for a second, right? We have like a little bit more, what to say, efficient version here, right? This is a different like logic way that uses a map, right? And maps are almost always like a when it comes to performance improvements, right? It's a very good friend of every developer, right? Why maps has a lookup time and of I of one, right? And I think even the insertion time and everything is like very efficient maps and hash sets, right? So that's, and it will have an offset of like you might have an increased memory, right, compared to earlier, but that's the trade-off you make, right? Memories are cheaper, and if it is not out of hand, right, it's always better to probably go for something like this, right? And here, if you see, we don't have a nested loop. Even though I am looping two times, it's not nested, right? I'll show what in numbers what it means later. But this time, what I do, I'll use this and let's see what happens, right? So I'll change this to use this. Let me rebuild my Docker and deploy. So everything else, the worker count, everything, we'll just keep it same. But let's see what happens with this, right? I'll review the overall performance so far. Like, yeah, our best one was like 570, but from there it was like, almost always downhill, right? It kept increasing. The RPS is something not very great, right? We never was able to cross like 2 RPS or anything like that. Okay, we are done. Let me check the curl to make sure. Yeah, it's working, right? Now, yeah, at the top we have, okay, everything is running. I'll start the locust again. Mm, I'll show you. Yeah, I think there might be, let's see with the load how it performs. So we'll measure the one user performance, right? Okay, now do you see like the response time. So I was thinking, did I make a mistake the first time? Then I looked at the numbers and it made sense. Like earlier, we were talking about 100 times more the response time, right? Just by the logic change, if you see the chart now, we are already at 5 RPS with a single user, right? Earlier, we were never able to cross 2 RPS. Why I wanted to include this is because I want to show you the impact of the logic you choose to implement, right? This is like how much difference when you compare the numbers, you'll get the idea, right? Now let's just go ahead and go for 10 users and see what happens, right? The responses time might go up, but it's okay. We are all already like what very much, even if it goes up to 500 milliseconds, we are good compared to earlier, right? But if you see here, no trouble, right? It's going up and yeah, the almost below 20 milliseconds performance, and we are at here, right? In fact, I don't think I can even test it properly now because now the load is going to be at the client end. So for example, right, when I want to test create more tests, right, you have to pass a param called process, which will say how many parallel process the locust itself will use, right? Because beyond a point with a single client, you can't generate enough requests, right? So for that, I can run 4 and let's go for like something high, right? So now if you see, we are getting around what 120 milliseconds, for example, I'll round it up, right? So we are looking at 1000 by 20. So we are looking at least 50 RPS, right? I Let's see if we can get, I think we can go even well beyond it, right? But we'll start with 50, right? And we'll see. I'll ramp up a bit faster. Okay, all the while, let's check the CPU usage, right? And yeah, I think we are hardly using one CPU, right? That's it. We are not even going above. I don't think we'll be needing two vCPUs at this point because and if you see, right, we are able to serve much more request, right? So at this point, we might not realistically need like two vCPU. And one thing I want to show here, right here, it might be going like 137, 82, 65, but here it might not really like here, like it's over a period of time, the CPU request is shown. There every burst will be shown, and also there is a delay. So again, we are well below 100, even when we are sending like what 50 requests. Yeah, and we are reaching a RPS of 200, right? And yeah, now we are seeing some degradation, but again, we are talking about 100 milliseconds, right? It's not even like it's still like 5 times better than what we were having earlier, right? And I think if the machine was not loaded, we would be seeing even better performance, right? And this is a great RPS, right? 216, compare it to like what? Again, this is a very niche use case. So don't think about like page extraction and think like, hey, we can achieve 200 RPS because that's like a little bit different, right? But the main reason why I want to show this, right? The difference is like very, very high, right? Now, if you think about it, it all makes sense. We said O of n square, right? That means we actually had like 5,000-ish characters earlier, right? So if you're doing in a single loop, right, it's only going to loop like 5,000 times, right? Even if you do 2 times, it's like 10,000, right? But when you are having a nested for loop, right? Yeah, you are basically squaring it, right? And I think this is something like 2.6 million loops that you are running, right? So for me, this is where like the software engineering practices kicks in, and you need to have this in mind while development, right? So if you're but at the same time, it's a balance, right? There is no point in hyper optimizing, and there will be a diminishing point of returns, right? It's a balance of how fast we can deliver things and how well it behaves, right? But again, if you make it a practice and keep it in back of your mind, right? I think it will naturally come to you, right? So let me just go back to my, yeah. So basically, these are my closing thoughts, right? As a software engineer, right, our main responsibility is going to be solving the problems at scale, right? Because the logic we are often writing is not very complicated, right? It's usually business logic, but there are exceptions. There are places where we do write like very what do you say, difficult problems. Usually that kind of problems lean in more into mathematical area, and it might be a different way of approach. But if you see 90% of our use case, it's all about it will be a simple business logic, but how well it worked at scale, right? How well it worked with one user, how well it worked with like 1,000 users and maybe like million users, right? In our use case, again, a million users might not be like the target, right? But what I'm saying, it's all about the scale that we want to achieve, right? And also it's about making the code development process and code execution efficient, right? So it's two aspects, right? One is like the development process. So if you think about development process, right, how fast someone new can come into a new code and start contributing, right? And how easy. So that all boils down to basically how easy someone can understand the code, and how easy someone can make a change to the code, but not break everything, right? So that is where like the kind of the things like clean code practices, solid principle, design patterns, microservice, etc. comes into the picture, right? It's all about those are the tools which will help you make the code development, its maintenance, and its extension all that easy, right? That is one aspect. Other aspect is like the actual running time, how to make it efficient, right? So that is where like the time complexity, data structure, algorithms, those are our tools there, right? So having a solid understanding of, I'm not saying like very complicated algorithms like the extra or something like that, but basic data structure, basic algorithm, basic understanding of the time complexity, right? So it will make us proactive and make us think how to write the efficient code, right? And at the end of the day, it's all about efficiency, right? Making it efficient, without causing the point of diminishing returns, right? And yeah, and if you see now, right, if we with the first algorithm, if we had to achieve, let's say, 200 millisecond, sorry, 200 RPS performance, right? We might have needed 200 CPU, realistically speaking, right? Now we are talking about with one VCP or two VCP, we are able to achieve 200 RPS. So in terms of the user experience, because they are getting a faster response, the deterioration is much lesser, and we are saving a lot of cost, right? If you see 200 VCP to VCPU, the cost difference is astronomical, right? And if you are able to do that, I think I don't will personally recommend a hike for you. So yeah, it's all about making things efficient, right? And yeah, I think these are my last takeaways. Get your hands dirty, because even for me, when I did it for Unstract and LLM Whisperer, is when it clicked for me, right? And I had these ideas in my mind, theoretically learning for interviews or in some courses I have learned, but practically it is like an investigative thing you have to do, right? It's not very straightforward, but once you start doing, you will develop that skill, right? So think about this, and what is it? Yeah, I think we are all individual contributors here, right? And we are mostly dealing with the low-level designs side of things. So that is where this entire efficiency lies down, right? Let it be the good coding practices which allows us to in future, bring in more people, or for even ourselves, right? And efficiency, all that lies with us. So we are the one dealing with it, right? So we have to be familiar with these things. And yeah, two simplest point, right? Avoid using nested loops when possible. Then again, dictionaries and hash sets are our friends, right? So yeah, I think I have one more session in plan. Maybe we'll dive a little bit into how the IO bound things. It will be little bit different, and with memory optimization, like some simple things, like nothing advanced, like what we can keep in mind.